Welcome to solverfy.
We know that the flux is entirely due to the field generated by the long straight wire. So we can use equation 2917, and we're going to then integrate according to equation 31. So we can then say that the absolute value of the flux is going to be equal to the integral from r minus b over 2 to r plus b over 2. We're going to say that we're integrating the magnetic permeability in a vacuum times the current divided by 2 pi r. This would be multiplied by a dr, and essentially this is going to be equal to the magnetic permeability in a vacuum times the current times a divided by 2 pi multiplied by the natural log of r plus b over 2 divided by r minus b over 2. And so we know that here r is going to be equal to 1.5 b. Therefore, the absolute value of the magnetic flux is going to be equal to 4 pi times 10 to the negative 7th. The units for the magnetic permeability in a vacuum are Tesla meters per amp or per ampere. This is going to be multiplied by 4.7 amperes, the current, multiplied by 0.022 meters times the natural log of 2, and this will all be divided by 2 pi. And we find then that the absolute value for the magnetic permeability, the absolute value for the magnetic flux will be equal to 1.4 times 10 to the negative 8th Webers. So this will essentially be our answer for part A. For part B, we can then implement Faraday's law in order to find the current of the loop. So we can essentially say that here, by using Faraday's law in order to take the derivative of the flux to find the EMF, and then we're going to use Ohm's law to find the current. So we can say that the change in the radius with respect to time would be equal to v, the velocity, and so the current of the loop by Ohm's law would be equal to the absolute value of the EMF calculated by Faraday's law divided by the resistance R. This is going to be equal to negative mu naught IA divided by 2 pi R. And then we'll have that times the absolute value of the derivative with respect to time of the natural log of R plus b over 2 divided by r minus b over 2. And b over 2. And so we find that the current in the loop will be equal to mu naught, the magnetic permeability in a vacuum, times the current times I times a b v divided by 2 pi r multiplied by r squared minus b over 2 squared. And we then solve for the current of the loop. This is going to be equal to 4 pi times 10 to the negative 7th multiplied by 4.7 amps multiplied by 0.022 meters multiplied by 0.0080 meters multiplied by 3.2 times 10 to the negative 3rd meters per second divided by divided by 2 pi r, my apologies, multiplied by r squared minus 2 pi multiplied by the resistance 4.0 times 10 to the negative fourth ohms, multiplied by 2 times 0.0080 meters quantity squared, close parentheses, and we finally find that the induced current in the loop would be equal to 1.0 times 10 to the negative fifth amps. We are forced to round to two significant figures, and this would be the final answer for part B. That is the end of the solution. Thank you for watching.